So, first, Chris and Tim are going to share a recap of last week's 25.3 release. Next, Joe is going to dive into some very exciting open source updates. And then we're going to hear from Joe and Denis, who are going to share an update on the Mojo roadmap. And finally, we will open up for Q&A at the end, as usual. So I'm going to hand it off to Chris to kick us off.
All right, thanks, Carolyn. So we'll dive into this recent release. Everything's been happening so fast. This has only been a week ago. The biggest update, I think, in this community meeting is the big news that I actually got a decent microphone. So hopefully you can actually hear me now, and this actually works better for everybody. So let's dive in. Just to contextualize things a little bit, I wanted to share how Modular's been working, what we've been doing. I recently wrote a blog post, this Democratizing AI Compute Part 10, and it talks about the process of building Modular and the process of taking on something that is industry scale in terms of complexity, in terms of opportunity, but also in terms of need that lots of people have been talking about. And so what we did is we spent the first 3 years building basically an R&D project. We wanted to see, could we solve this industry scale problem? Could we get the technology work? Could we get it all pulled together in a way that could make sense and then scale? And so we started this 3 years ago in 2022. Just recently in January, we got to work. We got to work end to end. We got all the pieces to click together. It was imperfect, but it actually worked. And once it works end to end, you can make it better and better and better and better. You can add new features, you can add new hardware, you can add new capabilities. And the team understands it. Right? And so what we've been doing since January has been really iterate, refine, polish, improve, add features, expand, and go and go and go and go forward. And so we've been shipping, I think, every 6 weeks. And now and at this point, we're in a completely new mode because not only does the technology work, but we're also very excited that we're getting enough of the features there that it's actually compelling. And so this is where what you're seeing us do now is we're opening up. And so 25.3 is a huge step forward for that, both with open source, but also our license and posture. And I'll be talking about part of that. And Tim will be talking about the other half this morning, at least morning for me. So this should not be a surprise. We've told people this. We've said that we're opening up. We've committed roadmaps and things like this. But I think people didn't believe us. And so I understand why that is. There's a lot of different reasons why people don't fulfill their promises or lots of things that could happen. But I'm very excited to not just talk about it. I'm very excited to do it. So this is what makes me very happy. And so if you didn't notice, we've open sourced, depending on how you count, 450K lines of code, but also if you count the amount of additions, it's more like 650,000 lines of code, because not only did we put the code out there, we also included the entire revision control history. And so you can go all the way back to see how it was built. This was built over the course of multiple years by a significant team of really smart people, much smarter than me. They're all building and collaborating and working on this. And so getting code out there, I think, is a huge step forward that enables new kinds of development, new kinds of applications, new kinds of extensions. And what we're doing now is we're opening up contributions and other things like that. And so other folks will talk about that later today. But I'm really excited. Again, this is a huge milestone for us. And so what does this include? This includes the rest of the standard library. And so there's like the GPU module and things like this that were not open. But the bulk of it is the AI kernel library. And so the thing that is really, really cool and very exciting about this is this might be the biggest portable modern integrated GPU kernel library that exists. There are some comparables out there. So if you look at like the PyTorch CUDA kernels or stuff like this, but it's not fully integrated because it doesn't include like the cuDNN libraries and things like this that PyTorch depends on. And so this is a really interesting point for the industry, and it's something that by opening this up, we hope to be able to both propel the industry and the technology forward, but also enable you all to help build and do cool stuff that's outside our immediate focus. And so I'm really excited to see people already like turning on the Turing architecture and things like this that we're not immediately focused on, but of course we'd love to help build into. So this is really exciting. We also have a serving library and a whole bunch of other stuff out there. And so the other thing we're doing in terms of making it more useful and accessible is pip packaging. This is fantastic. We love the magic tool and the Conda ecosystem and things like this, but pip is where a lot of AI developers are using. This also enables better integration with PyTorch and a bunch of other things. We've taken the first step with 25.3. We need to make it better in a variety of ways, and so we'll keep investing in this and keep improving the packaging. And happy to answer questions at the end. So if you haven't tried it out, please just pip install Modular. This is a big deal in terms of just enabling things to work the way they want to work. The major caveat I know of right now is that the LSP and the debugger are not included in the pip package, but that's something we're committed to fixing. Next. And so the other big piece is that not just are we opening up the code, we're opening up usage. And so Tim, can you walk us through this and talk about how it works?
Yeah. Hey, everyone. I hope you're all doing well. I think one other thing I'll just add in the spirit of Chris's comments to open sourcing all the code has been in terms of code generation tools, we've also seen a huge amount of interest in now being able to plug the repo directly into things like Claude Context or Windsurf or Cursor, and the reliability just because you have an expanded context window on some of those products now, and you have a lot of open source Mojo code. The idea of not only for Mojo but also for Max being able to generate code pretty quickly is something that we've seen uptake on very quickly. So if you haven't tried that, we'll also be doing more there, but you should give that a go if you haven't tried it. So very quickly, we did announce a new license. I think I'm not going to spend too much time going over it. We did talk about that a few weeks ago in one of the videos, but just quickly to recap the products themselves. So we have a framework, our AI inference framework or serving framework. We call that Max. And obviously we have our programming language in Mojo. Together, we really think about these things as the modular community edition. And so Max and Mojo now under a new license really enable you to build and scale anything. You get incredible performance across a range of architectures. You can read that in our revamped docs website. If you haven't checked out our docs website, you should do that. There's been a huge amount of improvements and fixes based on a massive amount of feedback that we've gathered from the broader community. And really, the community edition is free for individual and commercial use. Really, the only major restriction at this point is just in terms of some of the portability across to other types of hardware. But certainly for x86 and for NVIDIA GPUs, you're able to just scale freely, including into production. For other types of hardware, we enable you to do it up to 8 devices. And so this really gives you an enormous amount of flexibility in a very significant number of customer and user conversations. Folks are really excited about what we've done here and the positioning. We also have an enterprise edition. And in the enterprise edition, one of the things that we are working with actually now with a bunch of customers is a much more advanced inference solution. So today, the idea of disaggregated inference serving, where you can split up the transformer architecture into prefill and decode steps on much larger scale. This is something that becomes much harder to manage. It's not just a Docker container that you can horizontally scale. It becomes a much larger system. And in that regard, for folks who want to begin to really scale and are seeing scale in their workloads, we offer an enterprise edition, which today is self-hosted. We obviously help very much with that, provide a lot of support for folks. And of course, there's no restrictions here. You have unlimited portability across any type of architectures, including the ones that we haven't announced formally, although I think probably many folk here know the ones we have announced maybe not informally. Again, if you're interested in this, please contact us and we're excited to work with you. Together, this is really on the left, you should have strong confidence. And I think we've done a pretty consistent job here. And certainly we remain really strongly committed to the community edition. I think we've finally found a really great balance that people in the community are excited about. And equally, for the enterprise edition, we're really beginning to see a lot of interest in this product. We are already, like I said, working with a number of folks that we haven't announced yet, but this will be coming soon. And so together, this sort of forms the modular platform. I think we've recommitted to modular as our brand. And I think that's also really exciting because I think we've gone back and forth and we openly have acknowledged some of the challenges we've had with the infrastructure, but I think we've landed in a great place now. Again, just thank you to everyone who's given us feedback and really helped shape where we are today. Please just check out modular.com/pricing. I think it has all the details there if you want to find out more information. Again, this is just recapping what I already said in terms of if you're using it for research, you basically have no restrictions at all. If you are using it for production or commercial use, you just have some restrictions on portability, but otherwise it's very, very pro developer. You should be able to get out there, develop what you want. And of course, if for some reason you can't, you should just contact us and we'll work with you. Next slide. And then, yeah, lastly, just a massive thanks, I think, not only on behalf of Chris and I, but the entire modular team. There's so many people here who work so hard to deliver the infrastructure that we're building for the world. And of course, we couldn't do it without all of the broader community and all of the feedback that we get. Know that we're listening. We're trying to make changes as fast as we possibly can. Ultimately, yeah, we're hoping to change the world with what we're building here. And we're very excited about it. We hope that you are too. So with that, I will pass over to Joe, who's going to take us through a very exciting roadmap and other things. Take it away.
Yeah, thanks, Tim. Yeah, so we're going to continue on with some of the things that Chris was talking about a few minutes back. So as you know, now that 25.3 is behind the corner, you've seen that we've open sourced a lot of things here. The remaining parts of the Mojo standard library, which is massive. Like, as you guys know, when we open sourced the standard library last March, you had some code, but not all of it. And we said that the closed source parts were coming soon. Now they are finally here. But we've given you an extra set of surprises here. We've given you the kernel library as well. And so now you see all 500,000 lines of code of anytime that you guys sent a patch before, this is all the code that we had to go fix downstream internally. And so now it's all right in front of your eyes and you get to help us fix it as you send contributions. But we've given you one extra thing as well, the max serving library. And so now you see how the whole stack really comes together. And this is a very nice thing to see. But remember, we've always said that we were going to do this. I know that we got a lot of pushback. It took a little bit of time. We were still building. And so thank you for bearing with us. But a lot of our core tech is out there now for you to see. And so I know a lot of people are still processing the code and reading. It takes a while to read 500,000 lines of code. You can imagine how long it took us to write 500,000 lines of code, because a lot of this was written before Gen AI and code generation was even big. So thank you. Next slide, please. But most importantly, you get to see our velocity. We said that we wrote 500,000 lines of code, but we actually did it really quick, all things considered. We have a great team here. And so you can look at the full Git history that we released for both the standard library, the kernel library, and the serving. You can see how fast we brought up H100 support beginning in January of this year. It was just a matter of 2 or 3 months. You can see the progress day to day in each of the kernels. It's amazing. So I want to take a step back and look at the contribution policy. So we are still accepting contributions to the standard library. We're still getting a lot of contributions there, and we're happily supporting those. We're also going to be opening the door up for the Max kernel library starting soon. And so we've set a date for June 1st. We may be able to pull that in, and we'll let you know. But right now we're saying June 1st. Give us some time. We want it to succeed. We can talk more later if people have questions about how the build processes are changing, but I don't want to derail things right now. But stay tuned. An announcement will be coming soon. And then if we fast forward in the future, we're not currently accepting contributions for max serving, but if you read the writing on the wall and know our posture generally with open source, you can make some guesses there. So here are some general areas that we're welcoming support for. Note that we mainly, brought up kernel support for A100 and Hopper, and we're currently working on Blackwell as we'll talk about in the roadmap soon. But we still very much welcome contributions specifically for AMD in terms of their instructions, and as well as Apple's AMX instructions on CPU. There's a lot of fun kernels that you can write with like sparse matrices and other things like that. But we'll give a lot more of like call to actions as we open up support for the kernel library and contributions in the coming weeks. Okay, so that's it for the open source part right now, and now we're going to jump into the roadmap part of the discussion. All right, so what's next for Mojo? As part of our commitment to open sourcing, I think it's also fair for you guys to understand what's next, what's coming around the corner in the next month or two. So myself and Dennis will be talking about what's next for Mojo. Rob would normally be part of this, but he's not feeling well, unfortunately, so I'll be taking his part when we talk about the tooling stuff here in a little bit. So we're going to talk about the high-level focuses across all of the different engineering teams on Mojo. On the compiler side, we're adding various type system features. You can think of this as like language goodies, like nice to haves. There's a lot to talk about there, and this is what keeps Chris excited and keeps him hacking on the weekends as well. There's always a never-ending quest to improving the compiler performance and error messages. And then a couple other parts here in the library, and then we've got some tooling stuff. So on the library side of things, we've now open sourced the rest of the Mojo standard library and the kernel libraries, so that's done. We're still fighting this tensor dragon, so that is almost on its way out. We've had many different tensor types, and this is wrangling that complexity, and we've heard the user feedback, and we need to do something about that. Stay tuned, we're almost there. One of the things that's also kept the community engaged is Python Mojo interop. We'll have a lot more to share about that in the coming weeks, but we're really pushing hard on this. And then on the tooling side, we're still making improvements on the LSP, the doc generation. So this is the stuff you see on docs.modular.com, and just general developer tooling, both internally and externally. So there's some fun things to see there on the LSP. So to just help ground things in terms of the near-term roadmap, I just want to remind folks that Mojo is a relatively small team, but we have big ambitions. And so bear with us and know that we're laser focused on particular features for where the company is at right now in GPU programmability, and that we can lean into this complexity over time. But this helps ground what are the set of things we're currently focused on. It's like Mojo right now, we're aiming on making it an awesome language for GPU programming. And so that helps drive the near-term roadmap. And then I'm going to hand it over to Dennis now and talk about the compiler stuff.
All right, hey everyone. I think Joe, you basically said it all. So yes, We want to make Mojo a great language for GPUs. And at the moment, we have how many? 50 people, more than 50 people in Modular who write basically GPU code all the time, right? These are what we call our kernel authors. And they are our main audience at the moment. We really want to make Mojo helpful and enjoyable language for those people in the company who are using it day to day. And that's our main priority. Our focus right now is to help people who use Mojo day to day and what they want from us. I would say they want two things from us. First, they say, give us capability to write our code in a very concise way. The kernels, they're very complicated. They're complicated because they need to support a lot of different hardwares. They need to support a lot of different data types. And they need to make all the kernel algorithms to be composable with each other. So it's a lot of complexity. And for that, Mojo has a lot of features that make you able to write heavily parameterized code, right? So the code is concise, easy to read, and has a lot of contents in it. And so that's the direction in which we are being pushed, like add more capabilities, add more expressivity to the language. So we'll talk about that in one of the next slides. So the other thing they want from us, they say, look, we do a lot of iterative development. We change something in the kernels, we add some capability, we run a compile. We want this to be fast and relatively painless experience. What we want to do for that, we want to make the compiler faster so that you can do like quick iteration. And also when the iteration fails, we want to make it sure that you read the error message, you can comprehend what it's talking about. Right? Mojo is a young language and we didn't focus on the usability of it to the extent where we want it to be. So that's what we want to do now. So first, the type system expressivity features. The first one is like relatively simple syntactic sugar. We want to add trait unions. So if you have multiple traits, you can combine them together using the alias keyword. The second one is a little bit more complicated. We want to add parametric aliases. So if you have a type, you can kind of fix some of its parameters, while you leave the other parameters open to be defined downwards in the when you use scalar alias. The third one, you can say it's a syntactic sugar, but it removes a lot of duplicated code. We want to make you able to write functions in traits such that you can have a common implementation that can be inherited by all the structs that implement the trait. And the last one here, that's probably most contentious, is that we want to add a completely new thing to the language that requires keyword, right? Similar things exist in Rust and Scala, I think, and some other languages, where you as the author of the code can put up requirements and say that when somebody uses my algorithm, my struct or my function, in that context, if those requirements are not met, don't even try to use my code. Give the user a nice error message that explains to them what they're missing, what they need to do with parameters and arguments in order for my algorithm to be applicable. Instead of the compiler failing somewhere in the guts of my algorithm at compile time or runtime. Right? So that's actually a very big thing. We want to add a capability for you to basically add features to the type checking algorithm by saying this size, the value should be such and such. Otherwise, don't even try to use the struct in this context. So I think we probably will have more details about this feature in one of the upcoming meetings. It's a big one to design. Again, summarizing all this, expressivity in the type system, or like, as Joe said, goodies in the language to make the language more usable. That's one big thing. The rest of the plan is kind of self-explanatory. Anyone who used Mojo knows that the error messages are very verbose. And they not necessarily tell you what you want to do to fix the error. Right? So that's what we want to do. I don't know if we can succeed in 3 months. It's more like a direction. Yes, we want to make the compiler easier to use. Same is true about the speed up. The team spent a lot of time over the last year speeding up the compiler. I wasn't here at the time, but I think there was a lot of requests to make it faster. And we sped up it by making most of the compiler to be multi-threaded. The middle end, the back end, the code generation runs on multiple threads, right? Now we found that the front end itself, the syntactic check-in and semantic check-in, can also be sped up somewhat. We don't know how much, 10%, 30%, it's a guess, right? So hopefully by the end of the quarter, we'll have some numbers. Another thing we noticed is that if you have a runtime error, we actually don't give you a stack trace. We don't tell you where the error happened at runtime. That's something we want to fix. I don't know if we'll succeed in this quarter because this requires some investigation, but that's on the roadmap. All right, I think Joe, you take it from here.
Yep, thanks, Dennis. It's always nice to see what's next on the compiler roadmap. A lot of people, this is the first time that they interact with Mojo, and so it's great to see improvements in this area. And they feel the pain, so we're happy to see those get addressed. I appreciate it as well at the end of the thing. So I'm going to talk about the library team, and then we'll talk about the tooling stuff as well. So on the library side of things, we have our hands in many different buckets right now. Going through these at a very high level, the first one is open source stuff. That's kind of self-explanatory. We've talked about it in the past. The second bucket is core standard library evolution. Think of this as like general API improvements and like things that Chris recently made with small string optimization to string and that sort of thing. We talked about simplifying our tensor types and wrangling the complexity there, and we'll dive a little bit more into that in a second. Python Mojo interop, which we'll talk about, as well as Blackwell bring up and general improvements in API and ergonomics for layout tensor. So on this first part, I'm not going to beat this one too much because we already talked about it, but we've open sourced the rest of the standard library and the kernel libraries. There's a lot of code out there, full commit history. We're accepting contributions to the standard library now, and kernel library, again, reminder June 1st is the target date right now. So core standard library, we always make improvements. This is something that we're doing this quarter, but every quarter for the end of time with the standard library. And so this includes things like unsafe pointer, string, SIMD, you name it, like the core types used by everything. Simplifying the tensor types. So I think I forgot how many tensor types we had before all of this cleanup. I think we're at 13, 15, 17, something that was way too many. We're trying to get things down to very simple. So the mental model is going to be effectively you have a managed tensor slice when you're interacting with our custom op extensibility APIs with the graph compiler, and then layout tensor when you're doing kernel invocations. And so there's a lot of complexity that we're ripping out. We'll talk more later about the Max Mojo APIs and what's going on there. But right now, a lot of the focus is on what are we doing inside the kernel libraries. Specifically, some folks have seen things on layout tensor, ND buffer. And so we're going to write a user guide on like, how do we migrate off of these old tensors onto the new stuff? Where are things going? And what's the mental model around there? So stay tuned for that. But we need to get the ND buffer out of the kernel libraries, as we talked about. The goal is to just make things simple, make things easy and composable. That's the goal. Next slide, please. So Python Mojo interop, we'll have a lot more to share about this in the coming weeks, but I think what the exciting part here and things to focus on is what we're focused on right now is manual bindings. And so think of this as something akin to like PyBind or NanoBind for bridging the gap of you have some Python host process, you want to incrementally speed up the parts of it in Mojo where performance matters. And so typically that's done in C++ or Rust today. We're adding ourselves in this competition, if you will, for ways that you can make this accessible to the Python programmer to speed up certain parts of your program. We're actively using this in our Max serving stack. And so you'll be able to see this in the nightlies real soon of how we're actually shipping this Mojo Python importer and using this in production. This is really exciting. We'll have a lot more to share, but we also welcome you guys to kick the tires and we'll share more details on how you can get involved in this process in the coming weeks. Unsurprisingly, we're focused on new hardware bring up. This time around, we're working on Blackwell. And so starting from the ground up, we're working on these low-level intrinsics, like how do you allocate memory? How do you deallocate memory, do loads and stores? And so those intrinsics are coming together now, and now we can start focusing on the interesting kernels like matrix multiplication, attention, and that sort of thing. And so we'll have more to share, and you'll see some of this in the nightlies, like with the intrinsics. And then the last thing our team is focused on is general layout tensor improvements in GPU kernel programmability. Like we have a lot of internal engineers at Modular working on GPU kernel programmability, and our team helps support those, being the standard library team, if you will. So we frequently help out here with improving APIs. And then we're gonna pause for a second, just for a breather here, and then we're gonna transition over to talking about tooling. As a reminder, Mojo, we kind of think of it as three different groups. We have the compiler language, libraries, and then tooling. On the tooling, we're focused on three different areas right now. One is the LSP server, which is used by nearly every engineer that's writing Mojo code internally. And so we get a lot of feedback loops. And one of the things that we've heard is the performance isn't ideal. So we're focused on speeding that up, and we'll talk more about that and various bug fixes. And then we're also going to talk about the REPL and what we're doing there, and then also doc tooling, which is an important part of enabling docs.modular.com. So with the LSP, one of the things that we noticed is we are parsing way too much stuff. So LSP typically relies on the Mojo front end, specifically the parser. And so we were parsing the whole transitive closure set of like a given document. That was one issue. But also every time that we were doing incremental updates, so imagine you're modifying just like one part of a buffer, we were sending the whole document to every LSP request. So we have now fixed those performance issues, and you should see a huge improvement in parse time here, which manifests in LSP usage time and just like general usability there. Specifically, there are some files, like for example, we have one monolithic file, which I think is like 9,000 lines. That can still take a while for the LSP to parse. And so in those situations, we have particular SLAs, if you will, of what we would like performance targets to be. But to help bridge the gap in the meantime, we have a progress bar. That way you can see that the LSP isn't hanging or anything like that. It is still meaningfully doing work in the background. So keep an eye out for that. And then we also have various bug fixes as far as stability and performance in addition to those things mentioned before. So with the REPL, we've noticed it's not in a state that we're comfortable with and happy with. And so we've noticed some very critical bugs, and that we have mentioned in the forum a couple of weeks back that we are interested in investing in this thing for the long term. There's some technical details that we need to sort out and figure out long-term technical direction there, but we are actively working in this area and fixing critical bugs.
I'd also just throw out, thank you all for the feedback. So we didn't know that it
Yeah.
was actually being used quite as widely as it was. And so we kind of stumbled into making a set of assumptions about how it wasn't being used. And so thank you for letting us know that it's actually a useful tool. And so we'd like to fix it up. So thank you all.
Yeah, 100%. Given its use out in the community, we want to do this right and fix it. And so we're investing in it from an internal engineering perspective. One thing that may be underappreciated, but is actually super valuable is like what powers doc.modular.com. This isn't something we've really talked about publicly a lot, so I'll just use this as an opportunity. Like, we have a huge amount of doc generation that happens in this part of the compiler tooling stack, if you will. And there's a lot of exciting things happening here. You'd be surprised at how little code it is, but how much power and value it adds both internally and externally. It's quite enormous. So one of the things that we noticed is various inconsistencies in docstring section handling. So in API docstring, such as in the standard library, you'll see these sections of notes, parameters, arguments, things that are like part of the type signature. We've noticed some ways that inconsistency because it flows and just renders as markdown. And that leaves a huge open set to something that is normally pretty strict. And so we're working on inconsistencies there to lead for a better experience across the board. Moreover, in docs.modular.com, as you know from some of the Mojo compiler error messages, some of the type names are pretty verbose. And so we're looking to figure out how can we desugar those and apply the appropriate naming as far as when they surface in documentation. One of the recent features as well that we need to support at the doc tooling side of things is associated aliases. When you think about like the life cycle of a language feature, it doesn't just stop when you think about like the compiler and the front end knows how to parse said construct and do something meaningful in IR. It then needs to flow into actually getting used by the users in the library. That's one step. And then you have another parallel user, which is the tooling. And there's often tooling support. When you think about this, this is what holistically makes up a feature. And so all the things that Dennis hit on earlier, they have a lot of room to flow. And so you'll see this with parametric aliases coming down the road as well. And so thank you all for those that work on tooling. I know it's sometimes underappreciated, and so we really appreciate your work here. Next slide, please. I think we're going to open the floor up for questions.
Thank you so much, Joe. Thank you, Dennis. Thank you, Chris. Thank you, Tim. Now we are going to open it up for any questions about the roadmap, about 25.3.
There's a question in the chat about where we can see progress on the Mojo backend for PyTorch and if there are any docs about it.
So one thing I'll comment about, so we showed an example at the AGI House hackathon that actually can be done today. And what that uses is it uses our Max Driver API's direct zero copy interoperability with PyTorch tensors, which is present today in Max Graph. So you can set up a Max Graph, you can provide take a PyTorch tensor, you can use the DLPack interface to go across directly from that to a Max Driver tensor, run your graph, and then go back from there to PyTorch at the end. So this works today, and so we can provide an example of that in operation, but we're building even more ergonomic solutions for doing interaction with PyTorch to be able to introduce Mojo operations into custom PyTorch layers.
Thank you, Brad.
Yeah, and one other thing I'd say is that so Mark from the PyTorch core team gave a great presentation that'll be on YouTube when Carolyn has a chance. This all got built in a week. And so this is not like some super long-term effort. This is just, finally we're able to open some stuff up. We can finally get the collaborations going. And so like stay tuned for a lot of great collaboration. This is something that like hopefully it'll be upstream to PyTorch and like lots of other things there. And so we can get some nice cross-community collaborations. And so if you're, Gabrielle, if you're interested in helping with that, then please like stay tuned. And I expect the team will be sharing a lot more as it, they get a little bit decompressed over the weekend. So.
Thank you. Another question about, I can answer this one, about another Mojo hackathon in the near future in the Bay Area. Yes, we're hoping to do more hackathons, more events. We're also hoping to do some events and hackathons that open it up a little bit more widely, geographically, incorporate some virtual hackathons so that folks who are outside the Bay Area as well can participate. So I don't have an exact date for you, but definitely stay tuned.
And what I'd add to that is that we looked at this as the first of, right? So we really went into that both to have hopefully impact and learn a lot from y'all in the community, but also just to learn so that we could do it better. And so I think we learned a lot about our APIs, about language issues, warnings and errors that people are hitting, API polish, all the tensors that Joe was talking about and things like this. But also about the format and making sure that I think that next time we should actually invest more in teaching things and helping make it so that you could come with less knowledge and actually bootstrap within the event. And so I think a lot of the ideas will flow into these subsequent events, and stay tuned for that. I know many of the folks on this call, maybe not all the people watching the video, but a number of people on this call are already expert level at Mojo, and so maybe you're interested in contributing too, and so we can see about working together on that.
Thank you. Any other questions? Questions about the roadmap? Questions about 25.3? A question in the chat. I've developed a Mojo project that interacts with and depends heavily on Python interoperability, including significant custom modules. I've written in Python and Mojo. My experience with the Mojo debugger in VS Code was not great. Crossing the great divide between Mojo and Python for debugging seems to be problematic. Any resources I've missed that could help me use the debugger interacting with Python?
I'm happy to take that one. Can you share a little bit, if the person's on the call here, do you mind sharing a little bit more about your use case? You're having Mojo that's calling into the CPython interpreter using our Python modules in the standard library? Is that correct?
Can you hear me?
Yes, I can hear you.
Okay. So my application I'm working, it's Mojo code, compiles Mojo, but it's interacting with Python, and I've got a lot of stuff going on. Actually, at some point, I think I want to share that with the community and kind of get some feedback and whatnot, because it's not simple. But when I'm essentially the Python that I've written, the code that I've written in Python, all my tests I've written in Mojo. And so that makes sure that I can interact with the Python and it works. I can prove it in testing, and then I can use it obviously appropriately within the actual code on the Mojo side. But when something doesn't work, I'm left with getting basically print statements here and there, trying to figure out what's going on and trying to figure out where the ball gets dropped. Like, what's this value here versus what it shows up over here, and I'm trying to, things going on and passing parameters back and forth or values back and forth. And I've gotten really good at doing that, but the debugger, when I looked at it, I couldn't see a good way to go from, okay, I'm running Mojo code that calls in Python or does something in Python, and it doesn't, the end result, it doesn't work. But on the Python side, I have no way to use a debugger type tool to see what the variable looks like when it gets, and it's not just a variable like a single value. It's, it's some kind of a class has, data and
yeah.
Following that whole trace back and forth, I didn't spend a ton of time on it. So it's kind of I can't figure this out. So I'm just going to do what I know works and brute force through it.
Right. Yeah. Thanks for talking a little bit more about your use case. Help me understand the problem a little bit more. So I have some good news and some advice in the short term, and then I can tell you what may come down in the future. And I have some ideas that we're not actively working on. And so we'll talk about what can you do in the short term. So two meaningful things that you can do in the short term is, when you're interacting with another language, specifically via Mojo, you need to be very careful with the ABI mismatches that you may run afoul of. And so we have some things in the standard library, like these various C types, if you will, because one of the key things is when you're interacting with another language and crossing this boundary is the ABIs need to line up. If you're off by a byte, off by 4 bytes, you will overwrite data. You will end up with bad things on the other side. And this, you're trying to recover backwards by like working with a debugger, print statements, stuff like that. But Mojo right now, it is very much, it is a sharp knife with cross-language interop right now. We have some experience in this area, but you have very little safety. So tread carefully there is the first warning. Always be looking for how does this type in Mojo use its C-type equivalent for mapping into Python in that case. The other recommendation I'll give in the short term is C Python. If you're compiling that yourself, there's a way to enable assertions and other debug info like sort of thing. Having this sort of thing as you're doing the debugging, as you cross language boundaries, can be very useful. It is not the default typically in installations on your system, whatever package manager you use. So you have to sort of do that yourself out of band, compiling C Python with assertions and debug info.
Yeah.
So those would be the two things that I could recommend in the short term. I have ideas that I don't want to go too much into the technical details of around like cross-language debuggability. And there's some prior art and other spaces with other languages, but this is a huge, interesting area that I'm excited about, but we're not actively working on that area right now.
Yeah, my thought is it might be helpful to someone on the team they'll look at, here's what I've done, and then get some idea of like, okay, how could we, and maybe that's already out there. That's why I kind of asked the question, how can I improve, let's say, the usability of the development process and the debugging process? Because at this point, I'm like I said, I'm brute forcing through it, but it's certainly not using anything close to state-of-the-art debugging techniques.
Yeah, so I don't know the current state of the art of LLDB being able to talk to Python. And so this would be something that would be interesting to look into and just see, has anybody else even tackled that problem before? And so I don't think that we're planning on making LDB do that in the immediate future, just given all the other priorities and all the other stuff that was talked about in the roadmap. But if somebody else has already done that, maybe we can wire it in. Or if you're interested in poking at that, if there's a way to get the LDB, it has an architecture where it can talk to different language backends in its own kind of way. If there's a way to get LDB to talk to Python, then that would be the first ingredient to make it so that you could have like different frames across different languages. And so I don't know, I have no idea how big of a lift that is, or if that's already done, or I just have no context on that, but it would be worth kicking the tires on and see what's already out there.
Plus one to that. One other thing, Easy Writer, is if you are open to sharing your code, I recommend you open up a forum post and we can have a discussion there. Both, folks from the Modular team and other folks from the community can help give advice on debuggability and usability improvements, that sort of thing. And so don't feel like the weight is always on your shoulders. If you share your code, we're all happy to help here. We're a community.
Sure. No, appreciate it. Thanks so much.
Of course. Thank you.
Not a question, but a comment in the chat from Sora. The LSP still runs quite slowly when editing the standard library. I wish we had a performance diagnostic tool to determine whether the issue is related to my setup or a performance bug worth reporting. And Owen was just plus oneing that.
Yeah, I think Rob would be the guru to talk to this, but just as a weekend Mojo user, I see the same thing. I see the LSP just like spiral out of control and eat up all my cores. And so I don't know if that's the LSP being slow or if that's just a bug. And if we go figure out what it's doing, it's going in some infinite loop or something like that. Maybe it's just a bug that we need to track down. And so it would be great to figure out if there's a way to get some kind of logging or something so that we could figure out when, to me, it would be ideal to say, to instrument the LSP somehow to say like self-diagnose if it took more than 5 seconds or something, then dump the file to /temp and then log something, and then you could choose to upload the input or try to track some of this kind of stuff down. But it's hard to do that kind of stuff. The other thing I'd say is that the LSP is still parsing more than it should. And so the comments about you have a 9,000 line file or something like this, the LSP doesn't need to parse all the function bodies. It's currently parsing all the function bodies within the file, but it should really, if you're doing code completion or something, it just needs the current function. And so we can do more to make it lazier and continue to invest in that.
One other thing I'll remind you of is, even though we don't have a fancy perf diagnostic tool today, your LSP info log, it contains timestamps that are at that granularity to what you want to maintain. File bugs. If you're seeing a request, like you have the send request for each event in the LSP protocol, just file a snippet in your LSP info log that you have, file a GitHub issue. That is something you can do today without us building new performance diagnostic tooling.
Well, so I again, as a hobbyist Mojo user in my spare time, I wasn't aware of that, and like maybe it would be great to create a forum post and kind of explain what people can do there. That would be helpful.
Yeah, we can definitely do that.
Yeah.
Thank you. Question from Gabriel in the chat. Is this plan to be able to use the standard library without having to create a .mojo package file first from source files directly? Creating a Mojo package every time I run a standard library unit test is pretty slow. So I guess it falls into the compiler performance issue. I don't know why the standard library is packaged in a Mojo package in the first place instead of distributing source files. I'd be interested to know. Also, I don't know if creating a Mojo package breaks the compiler cache also.
Probably the best person, or Chris, to take this.
Yeah, or Dennis, if you know. I know you have folks working on this.
Yeah, I don't know the answer, Chris. You might need to help me on this.
I don't either. So.
All right, I'll take my best guess, and you can.
Packaging is my weakness. I don't. Somehow I've never learned how packaging works.
I can answer a couple things there.
Sure.
So yeah, like this came up in the hackathon. If you have a Mojo package there and you're doing custom ops in Python, it will stop the caching. So you need to delete that Mojo package so that it recompiles the cache properly. So yeah, that is one thing we need to improve. And then for distributing the source files, so you can just compile them directly. That is another thing that came up as well. Like when people are in the LSP, they can't go to definition and things like that. So that's potentially something we can improve as well. Because if it was able to just build the source files directly, you wouldn't have to repackage the standard library and stuff like that when you're working on it. So yeah, we'll definitely talk about that.
I think one of the things I'll hint at, Gabriel, that we'll have more to share about is like with the new build system overhaul that we're doing in the open source repo, the intent is to solve some of these problems. You still build a Mojo package because there's various layers in the caching in the Mojo compiler itself with how it works and how imports are resolved from Mojo packages rather than source and that sort of thing. But you should see a much better performance in the build system side of things rather than our shell script that always rebuilds the Mojo standard library and then runs the unit test. So keep an eye out for that. The part that Jack was talking about like breaking caching, he was talking about in the context of the extensibility APIs with custom ops and that sort of thing. If you're just hacking on the standard library, that's a separate sort of issue. Happy to talk more offline. Feel free to ping me and we can talk more.
Thank you. In the chat, although Modular has support for the Mac OS, the Mojo device context and has accelerator functionality, does not return any accelerator when it runs on the M4 Air. Does this mean it runs but does not utilize any acceleration?
Jack, do you want to take that maybe? Since you're piping up, or Brad?
We know that there's a lot of interest in running on Apple Silicon GPUs. And we are expanding platforms. So like we know that there's significant interest out there. But today we do not use the Apple Silicon GPU. I will point out that it does do some acceleration on Apple Silicon. If you look in our newly open source like standard library, for example, you'll see how we use the AMX. And so you can actually go and see how we do that on the CPU side. So we use some acceleration on the CPU side for running on Apple Silicon, but we don't yet have Apple Silicon GPU support. But we may have some more to say about that at some point in the future.
Thank you. Final call for questions. Going once, going twice. All right, if there are no other questions, we will end it here. But thank you everyone for joining us. Thank you for the awesome questions, and thank you to our presenters. And we will see you next month.
Yeah. Thanks, everyone.